It's Metal Clock with Mr. Hlajwayo. Welcome to another video.
The mining today is we are looking at Theorem 2. So now, according to Euclidean geometry, now Theorem 2 states that now an angle at the center is twice the angle at the circumference, right? So now it is important to understand that now this is going to be your angle at your center, which is going to be twice your angle at the circumference. But how do we go about proving it? So now firstly, you are required to prove. This is what you are required to prove. You are required to prove that angle AOC is twice, or it's 2 times ABC. This is what you are required to prove. So you are going to first start by providing a construction. So you are going to construct this line segment. You can just extend it, right? You are going to provide a construction. This is going to be your construction. So you're going to construct a line. This is going to be your line BO. And it extend a little bit. So now you're going to firstly let this be your 1 and also be your 2. Now what else that you're going to let? Let's say you're going to now let now angle ABO. Angle ABO B equals to, when I refer to angle ABO, I'm saying angle ABO, which means it's this particular angle. You are going to let it be equals to your angle X. So which means this is going to be your angle X, right? Then what else you are going to do is you are going to let now your angle now CBO being this particular angle, this be your angle Y, right? You are going to let this be your angle Y. Then we are going to start with our proof. So when we are starting with our proof, the first thing that you are required to do, look, firstly, if you look at your angle O1, now you know that if you are having your triangle like this, right, this particular angle is always going to be equal to the sum of these 2 opposite interior angles, right? So your exterior angle of your triangle is equal to the interior 2 opposite angles. Okay. So which means now we are going to say now your angle O1 is going to be equal to what? It is, in this case, it's going to be equal to this angle X and also angle A. You are going to say your angle O1 is going to be equal to your angle X. It's going to be equal to your angle X, or your X plus going to be equal to your angle A. Now, what is going to be your reason for this one? This is because this is an exterior angle of a triangle, which is equal to the interior opposite angle. But this is an acceptable way of reasoning. So if you write this exterior angle of a triangle, it is absolutely correct. Now, from there, you're going to say now, but if you look at this angle, now, can you see that this, your BO and also your OA, these are your radius, right? Which means those sides are equal. So if these sides are equal, which means it forms what we call an isosceles triangle. And you know that the base angle of your isosceles triangle are equal, right? So if your base angle of your isosceles triangle are equal, so therefore you are going to say but, which means now this particular angle, your angle X is going to be equal to your angle A. Can you see that? Because these angles are your base angle of your isosceles triangle, right? They are your base angle of your isosceles triangle. So therefore, which means you are going to say actually now, which means your angle O1. Your angle O1 is therefore equals to same as X plus X. Can you see? Because your angle A, which was this one, is also equals to X now. This is also equals to X now. So therefore, which means this is going to be your angle O1. Therefore, your angle O1 is going to be equals to 2X, right? But similarly, if you are going to look at this particular triangle now, if you are going to look at this particular triangle, which is OBC or CBO, anyhow you call it, can you see that these triangles are almost congruent, right? So which means whatever that you've done here, it's going to be almost the same thing that is going to happen here, right? So which means you can conclude by firstly saying, now you know that this angle C or your angle C here is going to be equal to your Y. Now, which means you're going to say, simply from here, you're going to say now, similarly, you're going to say now, similarly from here, you're going to say, similarly, this now, your angle O2, is going to be equal to what? Your angle O2 is going to be equal to what? 2y, because this is going to be the same thing. Look, this is an exterior angle of this particular triangle. So which means this exterior angle is equal to this angle and also this angle. And since this is your radius and also this is your radius, and this forms your isosceles triangle, right? So therefore, this is going to be your angle and also this is going to be your equal angle with this one. And don't forget, as soon as you are mentioning this, that here, remember here we said your x is equal to a. Don't forget that here your reason is going to be angles of equal sides. This is going to be angles opposite equal sides. Okay. So similarly here, this is going to be the same. This is going to be the same thing that's going to happen between these particular angles. Now, if you look at this one now, okay, if let's say now we are saying, now let's say you want to add your angle O1. You add your angle O1 plus your angle O2. Your angle O1 and your angle O2 is going to be equal to, remember we said your angle O1 was equal to what? Was equal to 2x. So which means this is 2x, right? Now you said also your angle O2 is equal to 2y. So this, if you are adding this, this is going to be equal to your 2y. Okay, so this is going to be your 2x now plus your 2y. But now if you can look at what is actually your angle O1 plus your angle O2. So you can make reference that actually this is AOC, because AOC is made up of angle O1 and also angle O2. So you can write this as now that your angle, therefore AO, your angle AOC. Your angle AOC is going to be 2x plus your 2y. Now here, if you can check, you are having a common factor, which is what? Which is your 2. So which means your AOC is going to be equal to 2 into bracket x plus y if you take out the 2 as your common factor. Now from here, now what is your angle x plus 1? If you go back here, look, your angle x plus y is basically this particular angle. So which means what you can do here, you can say now if you can reference this as your angle ABC, because ABC refers to this particular angle. So which means actually your angle AOC is going to be equal to 2. What is x plus y? X plus y, it can also be written as ABC. So therefore you have proven what you are required to prove, that AOC is twice angle ABC. Then this is going to be your second proof of this particular theorem, which is your theorem 2, which states that an angle at the center is twice the angle at the circumference. But if you are starting from your circumference, you need to know that now the angle at the circumference is half the angle at the center. Then that's going to be theorem 2. Thank you very much.